My name is Eric Sprell. I'm an engineer at OmniTI, and this is a story about how we solved a business problem using ZFS. So anybody who knows Dr. Strangelove, it's a great movie, ripped off that line. I'm a build engineer. I'm a sysadmin by trade. I'm also a consultant. OmniTI is a consulting company, but we also do OmniOS, which is a distribution of Illumos. It's been mentioned a couple of times. And I also work on Circonus, which is a software as a service monitoring platform that we made. So the recipe for success today is the concept of enablement or empowerment. And this is about how ZFS enabled us to solve an acute business problem for one of our clients. The background is that the client in question is Etsy, which I'm sure most of you have probably heard of. They are the world's handmade marketplace. They were and still are experiencing rapid growth. Seems like every year they go through another round of growing pains as their user base increases. And like most businesses that are rapidly evolving, all of the different pieces of the business, from revenue to marketing to operations, need to understand how the business is evolving. So they need data, they need feedback from how the site is working, how the application is working. And they were running into some pretty acute database problems, and they came to us and asked for some help. So the situation that we walked into was that Etsy had no data warehouse at the time. All of the data that they needed to generate their business analytics was stored in their main OLTP database. And if you're probably mostly familiar with the concept of OLTP, but it's a transactional database. So low query latency is the key. This is backing the website. So most of the ways that customers are interacting with the site and the application have to do with the database. It's directly related. So when the database doesn't perform well, the website doesn't perform well. It was already pretty large. It was about 250 gigs when we walked in, and the forecast, the way the numbers were looking, it was going to be over a terabyte very quickly. So as I alluded to, running really long, complex SQL queries against a transactional database really destroys its performance. It sucks up the limited amount of system resources that are available and causes the queries that back the website to get delayed. And as we all know, that high latency really kills performance. The other problem that they were having is that these queries would take a long time to run. They may take half a day to run at full speed, competing with everything else. And let's say there was a problem, something didn't go right in the query, and rerunning that report, because the data is constantly changing, rerunning that report would give you different results if you ran it the next day. Finally, the reporting interface was pretty inflexible. There were some canned queries that it was possible to do, but anything ad hoc or any changes you wanted to make, you had to go through a DBA. And DBAs are really busy, and it's not a really good use of their time to help people do their reporting. So we worked with Etsy and came up with a list of requirements, some of which are on this slide. The main goal was to relieve pressure from the OLTP database. We knew that we had to get that query load off. It just is not the same pattern of access. It's not what that database is really for. So we needed to get that off onto a separate system. But we still wanted to have all of that important data continuously available. We didn't want to have to be looking at stale data to make decisions. We wanted to enable correlation from other data sources within Etsy. So they have lots of other systems that have databases that aren't part of the main production instance. For example, they have a web forum that anybody on the internet can sign up for, as well as their paid and registered users. And they wanted to do a join between the users on the forum database and their active users when people were complaining about the site not working right or whatever it was. They wanted to find out how many of those people who were complaining were actually registered users of the site. That was very difficult to do in a granular fashion with the production database. You definitely don't want to pull in more data and make that database bloat even bigger. So we needed to figure out a way to enable them to bring all that together into their analytics database. And we definitely wanted to fix the reporting interface. We wanted to make it more flexible, more user-friendly, more self-service. So our solution was to create, obviously, a separate analytics database. And this will be custom built just for the job of running these big, long, complex queries. We knew we wanted to build it on ZFS because we'd had some experience already operating data warehouses on ZFS. We found it to be extremely scalable and very, very easy to administer, which was really key because we knew we would be talking about really large amounts of data. So initially, the system, when our database guys got into the problem, they were using ETL, which is extract, transform, and load. That's taking data from one database, massaging it, and turning it into another format. So think like extracting MySQL tables and putting them in Postgres, which is one of the things that we were doing. It enabled us, because it was running on separate hardware, these big gnarly queries that were running all day long didn't have any more impact on the website. And we also brought some of our web development team to bear on the UI problem, and they knocked it out of the park with a great web UI that made it really easy for anybody within the company, regardless of their level of technical skill, to come in and run reports, to make changes, make new reports, or just run an SQL query if they so desired. So what are some of the benefits that ZFS gave us? First and foremost, the ability to snapshot the data. It allowed for database backups of the analytics database to go much faster because ZFS Send is much faster than rsync or tar or pgdump or any of the other ways that you traditionally back up data files. It also made it really easy to create slave copies of the data. So we could just do a snapshot and a send of the database files over to another machine, bring them up in read-write mode, and go do stuff with them. Compression is a huge win. It's transparent to the application in ZFS, so it just happens down inside the ZFS stack. Applications don't really care if the data that they see looks uncompressed to them. So on this slide you can see that the Postgres database size, as Postgres sees it, is 1.3 terabytes. That's as of a couple of weeks ago. But on disk, that actual 1.3 terabytes only takes up 650 gigs. So we're getting 2x compression, and we have been for the last couple of years that we've been doing this. Also, intelligent resilver, which is the concept that since ZFS it has awareness of the entire storage stack from physical devices all the way up to file systems, that when a device fails, you know exactly the blocks that were live on that disk. So instead of having to do a dumb block 0 to block whatever copy of an entire device to rebuild it, you only have to rebuild the data that was actually in use. And that really shortens the rebuild time, and as a result, reduces the risk of data loss from overlapping failures. So imagine that you lose one half of a mirror and you start to reconstruct it, and then the other half fails. Well, you've lost data at that point. So the less time you spend rebuilding when you have device failures, the better off you'll be. So at this point, we have these big monthly reports that used to take a half a day on the production system are now running on the analytics system, and everybody's happy and delighted. But then we still have this problem of continual flow of data coming in. So if this query doesn't work right, or the report has a problem, and you need to rerun it, you still have the problem of getting different results running the same report on different days. And we also need, since we have this flexible UI and people are now creating their own reports and making modifications to reports, we need ways to test that safely so that whenever they're going to be doing anything that could change data with the report, that we provide an environment where that can happen safely. You can develop the report with a small mock-up of the data. You can copy it to your laptop or whatever and test it. But to really understand if this report's going to work in the full-scale production, your staging environment needs to look like production. It needs to have something that looks like production data. So we took it to the next level, and we started creating these disposable environments. Since we already had a Postgres master and slave set up, we decided to use the slave database because it was really, other than replaying events from the master, was otherwise idle, had resources to spare. And so what we wanted to do was create a read-write copy of the main database data that we could throw away when we were done. It was just going to be used for the duration of the test or whatever we were doing. And so we combined that with the non-global zone, so zones technology, where we can create we can carve out a separate application environment that shares a lot of the resources of the system, so it runs like it's on bare metal. It's lightweight virtualization. And the details of the zone config aren't that important except for what I've highlighted in red, which is the idea of ZFS delegation. So you can take a portion of the ZFS namespace and delegate control of that hierarchy to a non-global zone, so that users inside the non-global zone now have full control over that data. They can take snapshots, they can create new data sets underneath that. They can destroy, reset any of the settable properties on ZFS. So as an example, the starting state that we have on the slave, we have a data directory and we have a wall archive directory. So if you're not familiar with databases, the write-ahead logs are the record that we use for point-in-time recovery. So at the point that we make this copy, there may be some data in flight, some transactions that are committed to the log, but the data hasn't actually made it into the on-disk data files. And so what we do is we just play forward from the archive logs to get up to a consistent state that we can start using that copy of the database. So the first thing that we do is we take snapshots of this data. And the interesting thing here is that we're using the recursive snapshot feature, which is ZFS snapshot-R. And when you give that a top level in your hierarchy, it will instantaneously make snapshots at all of the descendant children, the child data sets. So, and this also happens atomically, which is the key thing. So all of these snapshots from this hierarchy represent the same moment in time. It's very important when you're coordinating write-ahead logs and data files. And lastly, we actually create the clones. So we use ZFS clone, and the arguments to that are the source snapshot that we took in the previous slide. You always need, in order for you to have a read-write copy, you need a fixed point of origin. And at this point, I'd make a Stargate joke and draw a cube on the wall, with the line coming out of it. So what we get at the result is this hierarchy under BI1 tank stage. And if you remember from the zone configuration, stage was the top level data set that we delegated to the zone. So now when this zone is running, it sees this hierarchy appear inside the zone, and it has full control. So why is this useful? Because we could just take this data and copy it anywhere we wanted to. But it's a lot of data, and that's a non-trivial amount of time to do that copy if we were going to send it to another machine. The advantage here with ZFS is that this is very lightweight. So initially, everything in this copy is the same as in the origin. And so it takes practically zero disk space. And it's very quick to create. It takes just a few seconds to create this. And the only penalty that we're going to pay is when we start to change things in the clone, those changes are going to accumulate to the clone. But anything that we don't change remains referenced to origin and doesn't cost us any additional space. And since I'm kind of a visual person, I will attempt to represent this in some way that makes sense. I hope you can follow along. So on the left, we have the live file system, which is our sort of starting state. We pick a point in time and take this snapshot. So initially, our stage snapshot looks exactly like the live file system. And of course, after we take the snapshot, the live file system is going to continue changing as well. But then we build our clones off the snapshots, and any data that we don't change is going to reference back through the snapshot, and maybe even back to the live FS if it happens to not change. So we really get a huge space savings there. And any blocks that we change get accounted to our clone and will be freed when we destroy the clone. So the result of all this is that we now can rerun a report. So we can set up one of these environments to run the monthly report that takes a half a day or more to run. And if something happens, we can just roll things back. We can roll back to the origin snapshot and start over. It also allows us to, on a single report basis, to massage existing data. So we can, if somebody needs to bring in one more thing just for this month, or run some sort of ad hoc report, this is a completely writable copy of the actual data, so they can do whatever they want with it. And it also allows developers to test changes to the user interface, and anybody who's working on reports can do this testing. So as I mentioned before, when you actually want to commit this changed report to production, you need to make sure it actually works on real data. And so when we're finished with the environment, we just shut down the zone and we delete the clone and the origin snap, and that frees all the space back to the pool. And one of the downsides to this is that depending on the velocity of the change in your data set, just merely having the snapshots around, let alone the changes that you make in the clone, it does hold on to data that might otherwise be freed in the live file system. So you do have to watch and pay attention to how much space is being used by your snapshots and clones. So it's always a good idea to monitor the amount of data in your pool, how full it is. So we saw some pretty impressive returns on this. This business intelligence database runs on 2 machines. So we didn't have to invest in a lot of hardware for this. To make all these copies, we can run multiple copies in parallel, as much as the machine will tolerate in terms of actual CPU and memory load. And one of the biggest wins was that we actually got more time out of the production OLTP database. It was able to absorb not only it was able to sustain the traffic that it was getting at the time, but over the next 2 years it absorbed all of the website's growth, which is enormous. If you go to Etsy's blog, every month they release a weather report that talks about how many items were sold, how much revenue they had, how many people came to the site, how many new users signed up, and every month it's just enormous month-over-month gains. At this point, I think August is the most recent month that they have available, and they had 1.4 billion raw page views in the month of August, and they do something like 15 or 16 million dollars in revenue each month. So that's a lot of data. It's a lot of data, and a lot of value derived from not having to replace those big database machines as frequently as they thought they were going to have to. And also just the ability to move faster, to be more agile and get more granular reporting and customized reporting enables much better decisions by everybody, by ops, for capacity planning, for revenue, for marketing, to judge how effective their initiatives are. And basically anything you can think of, any analyst will tell you that business intelligence is where it's at. Mining your existing data for knowledge about what your users are doing, to inform all the aspects of business is really crucial. So we're only going to see more of this. We got a couple extra bonuses too, because we have these disposable environments. We can also test application upgrades. So if we want to upgrade to the next version of Postgres, since it is an in-place upgrade, if you don't have a copy of the data or a backup, then there's no going back if it goes bad. But this way we can safely test it. And likewise, any schema changes to the database where we're changing the relationships between things can also be safely tested with one of these environments. All of this technology is available in Illumos and all the distributions that are built on it, so I encourage you to take this and go solve some problems. Thank you. Anybody have any questions?
Do you need to care something Postgres when you take a snapshot? Like, especially buffers important or drive, or can you just go ahead and
The question was, do we need to stop Postgres to take these snapshots? The answer is no, because we're doing this on the read-only slave. So it's doing point-in-time recovery. So basically, whenever we want, we can just take a snapshot, and then if things aren't, Postgres will take care of playing the wall archives forward to get us up in a rewrite mode. Yes?
Just a question. I actually gave a tutorial on this at the Postgres conference
Cool.
a few weeks back, and the question I kept getting was, what about out-of-order writes? It's like you're writing the transaction files that do the point-in-time recovery, and then that's getting written to disk. And I was confident that everything's fine, but they kept saying, well, what if you get the write to disk before you get the write to the from that transaction log actually gets put on the physical disk. So somebody in the CFS community was really, it happens in the order you tell it to happen.
I might need to let one of the more expert people answer that.
Yeah, so when you take a snapshot and then create a clone like you're doing, it's the clone kind of sees the same state as though you had like pulled the power plug on the machine and then plugged it back in, right? So the database already has logic to be able to deal with like, oh, if I'm doing out of order writes to my data files, then I've also wrote some stuff to my log to make sure that I'll know how to fix that up when, if I lose power and come back. So normally,
you don't start having transaction groups, out of order writes don't happen.
but the data.
Right? Logs is kind of what take it to get it. You want to be as high instead. Logs are higher instead.
Yeah, so the database, can do writes that are out of order from its point of view. So it's saying, okay, I have a bunch of writes, I'm going to issue them all in parallel to my data files, but meanwhile I have my log files so that, even though all those parallel writes, some of them might happen, some of them might not, I know that, and so my log files allow me to recover from that. And they have to do that anyways to be able to handle like pulling the power plug on the machine. So, by doing snapshots and clones, we're kind of doing the exact same thing. The database is seeing the same sort of behavior and consistency guarantees that it would see in the power loss case. So you have to go through that recovery, like you said, when you bring up the
Right, and so in our use case, it's not particularly important to get to a specific point in time, just that what we have is consistent and we can just bring it up and start messing with it.
Because you think of the database as a crashing system.
Correct. Yeah.
Yeah, my experience told me that. We have a climate database coordinating constantly with this snapshots for a while.
Yeah.
So I just want to be able to, somebody asked me.
Yeah, because the wall archives.
Yes.
Yeah, the wall archives are written with fsync, so they're synchronously written and they're committed to stable storage before that returns, and so your snapshots are fitting right in between those wall updates, and you're going to have something. If you want to actually try to aim for a certain point in time, that's a little bit of a harder question.
Before you do what he did to make sure that you do the recursive snapshots, so that your wall.
Yeah, if you have those on different file systems, then you definitely need to think about how they're organized so that you will be able to do those recursive snapshots. Yeah. Anybody else? The question was, what's the Z-pool configuration? I believe on this system it's stripes of mirrors, so effectively RAID 10.
What about your configuration of your GIL and ARC? Are you doing anything with that? Database?
The question was whether we do anything specific to tune ZIL or ARC. I'm not aware of anything specific on the system. It just works, which is really cool.
What big was the box?
That box, so we started this project a couple of years ago. That box is it's an HP of some fairly recent vintage. I think it's got about 96 gigs of RAM and a couple of MSA shelves attached to it. So it's by today's standards, it's kind of a middle of the road box. It's not going to break the bank, but it's also no superstar.
Did you have to even tune the block size, like the ZFS record size?
Yeah, we set the record size to 8K to match what Postgres expects. Yeah. Any other questions?
What were some of the key takeaways from this project? There must have been one of these.
The question was, what are some of the key takeaways from the project? Well, I think more than anything, we learned that we can use the technology in this stack to solve real business problems that actually make have significant revenue impact to the customer. So Etsy is able to answer questions that they just couldn't answer before, and they are also able to beat the living daylights out of this database without having their website suffer. So, that's it. The question was, do we consider doing ZFS send across machines? Yeah, we do that all the time. We use it for backup. So we take a ZFS snapshot. We do put the database in backup mode to do that. And we take a snapshot and send it off to a backup system. And we use ZFS send and receive in a lot of different ways at OmniTI. So yeah, there's endless ways to massage that stream of data. The question was, did we see performance issues? Could you be more specific? Interesting. We haven't really seen that, but I'll bet Matt can speak to why that might be. It could be pool fragmentation.
Yeah, I mean, there's a lot of reasons that it could be slow. One of the things that we use send and receive like in the Delphix product to do remote replication. And one of the things that we found is that when you're sending between machines, if you do it very simply, like ZFS send pipe SSH ZFS receive, then there isn't really enough buffering in the whole system to. So the problem is like the send is reading data off disk. And it's kind of reading it in fits and starts. So it's issuing a bunch of IOs, prefetching, doing read ahead, and then getting that data, then sending it over the wire, and then the receiver is receiving the data and then trying to write it to disk. So, neither of these things are happening exactly smoothly, right? They might be going at approximately 100 megabytes per second, but they aren't going, exactly 10 megabytes every 10th of a second. So we found that by putting a big enough buffer in between those was really important to getting reasonable performance of the replication task on a whole. So like the way that we did the buffering is like we had, our application stack is written in Java. So we did some buffering in the Java stack so we could do other things and massage data as it goes along. But we've also been looking at like we've looked at a bunch of other solutions. We should probably like write a blog post about this at some point. I didn't do this, but some of my colleagues did, like trying to tune like the TCP window sizes, trying to tune the pipe sizes. So like, because we're actually getting the data from ZFS, the ZFS kernel is generating that send data. It's coming up to userland to our Java process. So how does that data get communicated? So we tried like using a socket, we tried using a pipe, we tried using a named, what was a Unix domain socket, which is like a named pipe. And trying to figure out like how to tune the buffer sizes of each one of those. And I don't remember the exact details of what solution we came with, but yeah, Jeremy and Seb worked on that. So I'll definitely ask them to post a blog on the Delphix blog.
There are a couple of things people have used, and buffer is one of them. And the other case where ZFS send can be slower than other technologies if you just have horrible transaction churn, because ZFS has this wonderfully unfortunate property of doing things in transaction order, which is lovely and gives you lots of benefits if you pay a price for it. So it can be slower, especially if you have lots of tiny transactions all over the place. It's really cool.
A lot of it can be just I/O, right? I mean, a lot of times you just boil down to that system that just works this and this.
There was a question on the stream, I don't know if it got relayed to the room yet. Graham Perrin is asking, Eric mentioned monitoring of free space at the pool level For the sizes of pools in Eric's case, is 4% a sane threshold?
4% free.
That's
Or-
that's all I got.
Okay, I guess I'll assume that it's 4% free. That seems a little close to skating a little close to the edge. We try to aim for about 85% full before we start just thinking about expanding the capacity or doing something to relieve that pressure. So, but we're pretty conservative.
I mean, the Delphix product is like kind of the same thing that you guys are doing, but like for the Oracle database and with a different kind of market set. And we start issuing alerts to the user when it's 80% full. So I think a lot of it depends on the workload, but I mean I think 4% would be extreme for any, regardless of the workload.
Yeah, if you tried to do this on a system that was 96% full, you'd probably run out of space before you got done whatever you were doing with the clone, because the space would accumulate, and having that snapshot present would hold on to data that would otherwise be freed back to the pool from the normal activity on the live file system. And performance would suck, because ZFS works on a slab allocator like UM does, and when you get really full, you start having to spend extra time finding places to fit different sizes of things, and that gets really slow.
We've got one more question on the stream, and then I think we'll have to cut off and start the next talk. It says, what about adding a buffer option to the ZFS send command via command line option?
I think that's a great idea, and I think that whoever suggested it might want to come to the hackathon tomorrow and help us implement that.
This is C. Hare. I'm not sure where he or she is.
But I think that's a great idea. I think it would really improve the command line out of the box usability to add that performance benefit. We at Delphix we haven't done that because we're using this interface programmatically, and we have so many other things going on with the replication that we wanted to bake that into our product, into our particular use case. But that's a great idea.
Somebody else added, Google ZFS send-to-end buffer. Great blog post about it. We're using it and saturating Gigi with it.
Great.
So apparently somebody has done this, and we'd like to hear more about it.
Yeah.
We've done it in Accent, I can figure out who it was. That's not.
Maybe that's the next center person.
Yeah, I think that's just the grand tradition of Unix, right? Small, single-purpose programs that work together. So ZFS send is just sending you a stream on standard out, and you can do pretty much whatever you want with that. So, and buffer's a great solution. All right, thank you.
I think we'll turn it over.